What's up, guys? My name is Michael and welcome to my YouTube channel. And today we're going to talk about advanced inheritance. Basically, we're going to talk about aggregation and what it does. And I accidentally clicked down, so I'm scrolling back up right now. But aggregation is basically has a relationship. Let me just go down here. Okay, yeah. Aggregation is basically the has a relationship. What we're going to learn is what aggregation is, how to model it, what delegation is, how to model it, how to implement one class in terms of another one, how to use private instance, and yeah, that was pretty much it. Aggregation is basically the has a relationship. So it's basically here they had a class called name and a class called address, and basically an employee has a name and an employee has an address. So what that means, what that means is you could use aggregation to basically you have one class that has a type of another class. So here, because an employee has a name and it has an address, they have a instance variable of the type name and an instance variable of the type address inside the employee class. So it makes it easier to model like real world things inside, like instead of having everything in like a different in the same code in the same file. This is a has a relationship. The employee has a name. The employee has an address. Okay, that's what it is. So here they had the string class, which is what we had before. It's basically just using they're using an array of characters and they're implementing the string class, the object of the string class, to create objects of strings basically. And here it's just the same thing as before. So the constructor, instead they added a static member variable, which is just adds one every time like a string is created. It just adds one. That's the only thing they added. I don't know what this has to do with aggregation though. Yeah, okay. So this one does though. So the employee class, they have a bunch of the employee class, they have three strings. Its first name, its last name, and its address. And this is aggregation because they're basically creating. The employee has a name, which is a string object, right? They're having another class's the separate class's name, right, as a instance variable for the type for their instance variable. That's basically what they're doing. So like if you have like just like last examples of having like okay, the employee has a name and an address, right? And they basically created a string class so that it could store the name and the address and the last name. That's basically what they did. And this is aggregation because string is a different class, and they're using it as a instance variable for this type, pretty much, a type for this instance variable. Okay, so yeah, that's pretty much it. Accessing members of aggregated classes. So a class that aggregates other objects do not have special access to those objects, member data, and functions. Rather, it is normally exposed. So if this string class has like anything that's private, so this string class, right, if it has anything private, the employee doesn't have access to it. So like in this string class, in this employee class, right, it has its first name and its last name and its address, right? And these are all strings, right? If I do like its first name dot get, I don't know, first character in the string, and get first character is private, I can't do that. Like it's the same thing as like regular. It only has access to public members for the object. Just like declaring like it in main, like creating a string in main, it only has access to public methods and members and stuff like that. So that's what they mean. Controlling access to aggregated members. Okay, so here they actually had a constant function called get first name, and it returns a constant for their string. So they changed it in order to use the plus operator because you can't add two constant values together. Like C++ doesn't allow that. Like the point of constant is that you can't change the data. Basically, you can't change the data of what you're doing. So What they did was they just overloaded the get first name to be non-constant. So that's what they did. Um, okay, so there's also a cost of aggregation. When you have like multiple objects created, for instance, in this employee class, it calls the constructor that many times. So like the employee has its first name, its last name, and its address, right, as string objects for their instance variables. The employee, like if you create an employee, it actually calls the constructor of these things that many times. So as you can see in this example, they created an Eddie, which is an employee, right? Right here, they created. So first they print out creating Eddie, right? Then they created the Eddie employee. So what did that do? They actually called the string constructor 3 times because the Eddie employee has 3 string objects as instance variables, right? So that called the constructor of the string that many times. So like if you have a car that has seats and has like a wheel and has like, I don't know, a steering wheel, or it has like a windshield wiper or something, or like people inside a car, right? It would have to call that many constructors for each individual object in those classes. For every single class that for every single instance variable inside the car class, it would have to call that many times for that many. So like the car seat constructor have to call that many times. It would have to call that for the, I don't know, windshield wiper that many times. So in here, in this case, the employee had a three string objects, right? So it called the constructor of these that many times. So this is actually inefficient. That's a cost of aggregation because it calls that many times for the constructor. It actually makes it less efficient, but good thing is it's easier to read and stuff like that. So they call that the constructor 3 times because there's 3 strings. They set the name with char. So yeah, they set the name. They said, okay, I'm gonna create set first name with char. Then they did Eddie dot set first name, Edith, right? That called that constructor again. Okay, why did that call that constructor again? Because they did set first name Edith, right? So let's go back to Edith. Where's set first name? Inside employee set first name. Okay, so they had set first name, and what they did was they said its first name, which is this instance variable, equal to f name. They actually called the constructor because they overloaded the equals operator to call the constructor. Yeah, they did. Okay, so they said this object, its first name is equal to RHS.get first name, and what is get first name? The string in their thing. Get first name. Okay, get first. What does their equals do? Okay, so their equals does this whole thing. And yeah, it copies everything there. So that's why it called the constructor. It called the constructor that many times. So that's why for set it called the constructor for that. Let me just go down. Set last name. Okay, yeah. So for set name, set first name, it called the constructor again. And they called the destructor yes, and then they said string last name. So print out set name to last name. Then they created another string. They set the last name, and it didn't call the destructor. So why did it not call the destructor? Well, the thing is that there's no the object is not destroyed until it goes out of the scope at the end of the function, because they created like a separate string object. That's why. So the reason here, let me just explain this better. So originally they created they did Eddie.set first name with this string Edith, right? And that actually called the constructor. And as you can see here, set first name with char pointer, they actually called the star constructor. And the reason why it did is because it created a temporary string from the string edith, and it called that constructor, and the temporary string is destroyed immediately after it is used in the assignment. Here instead, here they had a string last name, and they actually created another string object, and this is not temporary. So it called the constructor, and then until the method's over, the destructor is called. Because this is a separate object, they created another instance of the class string. So that's why here they called the constructor, and then after that, you wait until the function is over, and then it'll cause a destructor. But until then, prints out the name, as we can see here, name. Then prints out the name of Edith Levine. Prints out the address, the word address. Prints out the address, address string. Prints out the salary. Prints out get salary. Then the three destructors get called because of the three instance variables that were strings. So those three instance variables that were strings, their destructors get called. And then after that, the destructor for our object of Levine, last name Levine that we created here, that gets called because it's the end of the function. So yeah. Okay, so copying value. So as we illustrated, created 5 constructor calls. This time, okay, so now this time they uncommented the static variable. So now they could basically just means that what exactly do they change? Oh, okay. So now instead they passed it by reference, so no additional employee objects are created. Okay, so that's because. So here, instead. Okay, so they changed here's what they changed. So before the creation of one employee object caused 5 string constructor calls. So now they rewrote it. This time the print statements are not used, but the string static member variable constructor count is uncommented and used. So now it shows the incremented each time the string constructor is called. Okay, so this time they just added the static variable, so that each time the constructor is called, it increments it by 1. As you can see, where's the implementation of their constructor? It should implement it by 1, increased it by 1. Okay, well, yeah, wait. Yeah, okay, yeah, constructor count 5. Show 5 were created as part of one reference. When the employee object is passed on line 2 by reference, no additional employee objects are created. So in line 82, yeah, no additional thing. It's still called the constructor 5 times though. So there's no difference. Okay, so aggregation before, yeah, there was no difference. All they did was just have a static instance variable, not static instance variable, a static variable that adds 1 every time the constructor is called. So that's all they did. Okay, so now let's go over inheritance versus aggregation. So there's difference between when you should use inheritance versus aggregation. Let's say you want to create a parts catalog. Well, the specification you've given defines a parts catalog as a collection of parts, and each part has a unique number, but parts catalog does not allow duplicate entries and does not allow access by part number. Well, this parts list is well tested, and you could build it based on cat. The thing is that there's a parts list class that we made before, right? I think I briefly breezed over it, but there's a parts list class that is created, and let's say you want to, instead of that has some functionality from parts list, like we want our parts catalog to have some functionality from parts list, but instead of reinventing parts list from scratch, let's do it in another way. So you would create the parts catalog class, and you could use aggregation like before and have it contain a parts list. Then the parts catalog would delegate management of, we'll talk about linked lists next time, but management of the linked list to its aggregated parts list object. So basically, what that would mean is that the parts catalog derived from the parts list and thereby inherit properties of the parts list. So this is, okay, my bad. So I skipped this. An alternative, so before, what I said before was that you now have use aggregation to make it contain make your parts catalog class contain a parts list, right? Now, an alternative would be to have it derived from the parts list. So now use inheritance. Use is a relationship. But is a parts catalog really the type of parts list? Not really. Like, is anything in the base class not going to be derived? Like, does the parts list have the same functions that are inappropriate for the parts class? Yeah, it does. There are some functions that are inappropriate for a parts list and a parts catalog, right? So you might not want to use public inheritance. But are you creating more than one base though? Like, is a parts catalog needs two parts lists to do the job? If so, you might want to use aggregation. But do you want to inherit the base class so that you could take advantage of virtual functions or access protected members? If so, you could use inheritance. But based on these questions, you might choose between public inheritance is a relationship or private inheritance. We'll go over private inheritance, or aggregation has a relationship. So first of all, let's use delegation. Why not derive parts catalog from parts list? Parts catalog isn't a parts list though, because parts lists are just ordered collections and each member of the collection can repeat. A catalog has unique entries that are not ordered. So yeah, you can't really do that. And it would be possible to inherit publicly from parts list and then override insert and the offset operator to do the right thing. But then you would have to change like an essential of parts list to have duplicates, right? So basically, instead, what we want to do is create a parts catalog that has no offset operator, does not allow duplicates, and defines a plus operator to continue adding stuff to the back of the catalog. So a way to do this is with aggregation. So what they did was they aggregated some parts. They had a parts list inside their parts catalog. If I could just keep scrolling down and find where they, okay, so here they have a parts catalog, right? What they do is they use aggregation. Okay, so I'm gonna have a instance variable, a parts list that's private, and it's gonna be parts list, and it's gonna be called the parts list. Okay, that's what they did. Well, you could see that it's they don't, so the clients of parts catalog do not have access to parts list directly, like we know that. You can see that parts list is declared as private, so the interface is as such the behavior of parts list is dramatically changed. Like the insert doesn't allow duplicates for the parts list, and the implementation, well, that part is passed in as a parameter asking for its part number. If there's no match found, otherwise no errors. Okay, so calling insert on its members, mechanics action, as well as retrieving from maintaining aggregated parts. So no reason for parts catalog to reproduce this code. It could take full advantage of the interface. So this is essentially reusability within C++. Parts catalog can reuse parts list, right? But they changed the implementation details of parts list. That's what I did. Thing is parts catalog, does it actually have a parts list? Like, does that actually make sense? Well, not really. So a better way to use this is use private inheritance. So if parts catalog needs access to prevent protected members of parts list, or needs to override any of parts list methods, then parts catalog would be forced to inherit from parts list. But because parts catalog is not an parts list object, and because you don't want to expose the entire functionality of parts list to the client of parts catalog, you would need to use private inheritance. Private inheritance basically allows us to inherit from another class, but keep the internals of that class completely private to your derived class. So one thing you need to know about private inheritance is that all the base member functions are treated as they're private. So regardless of their actual access level to the base. So thus any function that is not a member function of parts catalog, every function inherited from parts list is inaccessible. So like if so any function that is not a member function of parts catalog, every function inherited from parts list is inaccessible. So if I try to access something from parts list in outside using an object of parts catalog, it's inaccessible. Like if I try to do this in main, like create a parts catalog object and then try to invoke a method in parts list, it's inaccessible. Okay, so to clients of the parts catalog class, the parts list class is invisible. Okay, none of its interfaces is available to them. They can't call any of the methods. They can call parts catalog methods, however. So if your parts catalog methods can then access all, the difference is that parts catalog can have access to all of the parts list because parts catalog is derived from parts list. Okay, I don't know if this will make any sense. If I use private inheritance, right, I'm going to inherit for my parts catalog, I'm going to inherit everything from parts list, right? Everything, okay? I'm going to inherit them, at least all the public things, okay? Using private inheritance, okay? It's basically like inheritance. The difference is that if someone else outside wants to call methods of parts list, right? With the object parts catalog. So if I use parts catalog x equals the new parts catalog, right? And I try to do like x dot, I don't know, a parts list method, you can't do that. However, parts catalog still has access to methods from parts list. All the public methods, at least. Okay? That's what it means. Public and protected. So it is implemented as in terms of parts list. Okay, so this is a better way of doing it because aggregation just doesn't work in this case. So here, what they did was, I'm just going to go down to the part where it actually matters. They use private inheritance like this way. Class parts catalog, I'm going to inherit privately of parts list, right? So in this class, in the methods of parts catalog, I could still call methods of parts list. So like here, iterate. I could call this method because I inherited all the public methods of parts list. Iterate is a method in parts list, and I could call it. Now, difference is that this is different and this is better. Reason why is that basically it gives us functionality to allows us to inherit stuff from parts list without actually using a has a relationship. So here in the insert method, find is now directly called because it is inherited from the base class. Okay. So here in the insert method, they called find in insert. See this public method insert, right? They called find, and they're able to do this because find was publicly inherited from parts list. So they're able to do this. Before using aggregation, what they did was they had a separate instance variable for parts called the parts list. So what they had to do before was do the parts list dot find and then whatever function it is. And that kind of gets messy because a parts catalog doesn't really have a parts list. They're not really, it's not this, it doesn't have a parts list. A catalog doesn't have a list. Okay, so that's why this implementation, it might work, but it's messy. So instead they privately inherited it so that the user basically can't call the methods of the parts list, but they can call methods, but the creator of parts catalog can call methods of the part list and use it for its implementation. That's basically what they mean. So here they could call methods of the parts list and use it for the implementation for parts catalog. But anyone outside, they can't call methods and parts list because a parts catalog is not a parts list. So this is kind of like, it's like a workaround of aggregation and inheritance, sort of, basically. Okay, so now we're going to talk about friend classes. So what if you want to, okay, so here they had two things, a list and a node, right? But wouldn't it be good if you want to read, like be able to access, have a function access the private members of its class directly? Like you don't want to make it public or protected, because that is an implementation, a detail of part node. You want to keep it private, but you don't want to expose it to outside people, right? So what you could do is make it a friend. If you make a function in your class a friend, it has access to every private data inside of your class. So if you expose your private member data to another class, you could declare that class to be a friend. This extends the interface of your class to include the friend class. After a class declares another one to be its friend, all of the declaring class's members and data functions are now public to the friend class. So if a node declares this to be a friend, then everything it is now has access to it. It is important though that friendship can't be transferred. So if Joe and me are friends, that doesn't mean Joe is my friend. If you are my friend and Joe is your friend, that doesn't mean Joe is my friend. Friendship is not inherited. Okay, so friendship is not inherited. Okay, friendship is also not commutative. Like if class 1 is a friend of class 2, that doesn't make class 2 a friend of class 1. Like you don't want to tell the secrets of whatever it is. So here's an example. I created class 1, right? I could call, and I have an instance variable of befriended class, right? And it has this type. It's an object, whatever, of another class. If I make this friend, this means that this befriended class, this one, will have all the access to all of class 1's members, including private and protected. So if you make it a friend, it has all access to all of its members. So here, so here they made an abstract class. We'll just go over, where do they actually use a friend? I think they did. I don't want to explain linked lists right now, but they have like something called a linked list. It's basically just a pointer to another object of the same type, something you could loop through. It's like an array, but you could loop through it. So I'm not going to explain what this linked list does, but let me see if I could find where friend is. Friend. Is there a friend? Is there no friend? Oh my god. I guess I can't find it. Whatever. Okay, so that's basically what friends is. So if you have like part node, right? This class called part node and a friend class parts list. Parts list has all access to private values of parts node. That's what it is. So declare one class to another by putting the friend front and granting the access rights. That is, I declare you to be my friend. You can't declare yourself to be my friend. Okay, so if you declare one class to be a friend and another one, you can't declare yourself to be my friend. if that makes sense. So if I declare A to be a friend of B, I can't declare B to be a friend of A. Okay, that's kind of weird. Friend functions and operator overloading. So originally the C style strings can't be created normally. They had to use a character array, and they couldn't add the plus operator. Well, now they changed that. They've rewritten it using the friend operator. So now this gives this function have all access to all private values of the string class. So what private value did they need for the string class? Well, they needed let's just go plus operator. Let me just find the implementation quickly. See, this is the problem about C++. It's kind of messy. Okay, so what they needed the get length function, and they wanted to, let's just see the instance variables again. Okay, so they needed the pointer, its string, and they needed the length of the private variable of the current string. So that's why for the plus operator, they made it a friend function, because then they could have they use dot length. Get length. Where's the rule about the pointer? I keep forgetting where. Its string, its length. Okay, did they need its length? Its length. Okay, they didn't. I don't get why they made this. Why did they make this a friend function if they never used its length and then its string? That's really strange. Okay, maybe they explain it here. Are unchanged. The new operator is overloaded to take two string references and to return a string, and this function is declared to be a friend. Note this plus operator is not a member function of this or any other class. It is declared within the declaration of the string class only so that it can be made a friend, but because it is declared, no other function prototype is needed. Okay. Similar to the plus operator, except it takes two string accidentally. Okay, so they did this because, well, this plus operator, it's not really, friend functions aren't really inside of another friend function. Like, they're not really part of, well, they are. Oh, did they just use this friend function in the plus operator? Let me see. I don't understand why they made it friend. Okay, they had this one. Oh, wait, okay. So here they made the plus operator. Why did they make this a friend? This has the exact same implementation. Huh, that's strange. Oh. Okay, so they made it a friend function because, well, they needed to access I'm kind of wondering why they made this a friend function. Let me test it out without a friend. Alright guys, so I copied the code, and now let's see what happens if I don't make it a friend function. So they had two things overloaded. This one and this one. One's const, one isn't. On const object, see copy constructor. Okay, so let's not make this friend. Let's just see what happens. The plus operator. Ooh, what does it do? Plus operator is not found. Okay, let's like comment this out. Would this have a problem? No. Because the plus operator only works for... I see what's going on. Okay, so they overloaded this. In order to overload this plus operator, it needs to have the plus operator. It needs to know where the plus operator is. And in order to do that, we had to make this friend. And they made this friend because now this function has access to all the methods of the string class methods, and yeah, so all the methods of the string class, even the private ones. So they're able to find the plus operator. Because if I've commented this out and then save this and I commented this out, I get an error. Because to overload operators, normally they need the they only need one parameter. No, but that you could overload. Can you overload method? I guess this is an overloading the function of operator. This doesn't work because you're trying to overload the plus operator twice. Overload operators, and they can't find the plus operator. So to fix this, okay, let's how about I cancel that. They needed total length. Oh, okay, so they made it a friend function so that they could have total length. That's why. Like if I just do that. No, I actually don't understand why they made this a length. Total length is equal to inaccessible. Total length is inaccessible. That's very strange. You can't have access to .getLength. RHS.getLength. But getLength is accessible. Isn't getLength public? Is getLength not public? No, it's definitely wait. getLength is definitely public. Here, I'll make this easier to read. Alright, so we have public of this. These are the public things. These are the private ones. This should be... okay, put down in the comment section below why this doesn't work. Why does this have to be friend? I kind of don't understand why. Okay, put down in the comment section below. One of you viewers, help me understand why this has to be friend. Because friend is just saying that, oh, okay, I have all the private variables, access to private variables and everything of the string class, but they never used any of the in the method function. They never used it. See, all they did was okay, I'll just make this more readable. I'll make this even more readable. This just, I don't like this wave. Let's make it more readable. Yeah, they never used it. Like, this is a public method. This is a public method. Maybe it's because... Oh, I understand why. This I'm being stupid. This function is not part of the string class. This is just an outside function. So they don't have access to even to get length. Wait, no, they should. That's very strange. Get length is public. See? Accessor. Kind of doesn't make sense. Okay, put down in the comment section below why does this have to be a friend? Overloading the plus operator. If you could answer this, I will do whatever you guys want. Now, if you could, I'm joking. If you answer this, I will. That would really help the channel. Anyway, so that was just C style strings. Yeah, here they're overloading the insertion operator. I still don't get why that has to be a friend also. Because they don't use anything in the overloaded operator of the insertion operator. See, they don't... Well, okay, this I could understand why, because they need to use its string. vstring.its string. So I could understand why they need to do that, but... The other one I don't understand. Is declared to be a friend that takes an OStream reference and a string reference and then returns an OStream reference. Know that this is not a member function of string. It returns a reference to an OStream so that you can concatenate calls to operator calling left. This implementation of the friend function is on line 157 to 161. All this does is hide the implementation details of feeding the string to the OStream, and that is just as it should be. You'll need to see more about overloading this operator and operator greater. Alright, so that's pretty much it. Rate, comment, subscribe. I'll check you guys later.